All right, I hope you can see my screen. Excellent. Thank you very much for your attendance. Welcome to this session. My name is Luke Enriquez. I am the Senior Global Offer Manager at Schneider Electric, responsible for the Trio data radio product offer. In this session, I will discuss how you ensure that your SCADA radio systems are protected against hostile cyber threats. Even if you don't use data radios or other wireless systems, the concepts and technology I will describe are universal, and they can be found in many different industrial and utility applications. So I'm quite sure you'll learn something useful. If you do have any questions, please ask them in the Q&A box in the bottom left of your screen. At some point in time, most of us would have gone through the process of configuring encryption keys for a Wi-Fi network, be it home, office, or an industrial plant. And I'm confident that, like me, you too would have been frustrated when entering the same encryption key over and over. And the problem with encryption keys is that they are difficult to remember and change. According to the business research firm Entrust, 68% of businesses say key management is a major problem. Let's take a typical SCADA and telemetry end user, like a water utility. Just imagine for a moment how many devices with valid encryption keys are either lost or floating around in the back of someone's vehicle, capable of being powered on and potentially providing hackers unauthorized access to a SCADA system. And this leads us to the obvious question, is there a smarter method for securing wireless networks? Before we get into more depth on this topic, let's first provide some context. So we all know device security is a multifaceted topic. But for wireless devices specifically, some elements are more important than others. The physics of wireless communications opens a possibility of interception and injection of messages, something that's not as applicable for other types of communication, like wired communication. And so I would say there are three key elements that are more important for wireless communications than all the other elements of device security. And these are encryption, trust, and authenticity. And these three key elements apply to all types of wireless communication. And we're going to look at them in more detail in this session. Encryption, which I think most people are familiar with, is a process which enciphers a message so that its content is secret during communication. The encrypted message can then be deciphered by a trusted recipient with the correct encryption key. Pre-shared key encryption is the most common type of encryption in use today. This requires the same text-based passphrase to be configured in all wireless devices that need to communicate. Okay, so far it seems pretty simple and straightforward. But one problem is that pre-shared keys present a significant management problem for SCADA and telemetry devices like wireless data radios. Particularly because wireless devices, they're typically one-to-many networks, just like Wi-Fi networks at home. Let's explain this problem using an example. Let's say you have a data radio network and you have a field technician who has knowledge of your pre-shared key that you use for your encryption. He leaves the company and now he's no longer trusted. Okay, prudent practice is to change the encryption key in the radio system. But this has problems. Not only will the key need to be updated in all devices, but if being updated remotely, it needs to be perfectly entered without any finger trouble. Secondly, there will be some communication downtime, which lasts the duration of the reconfiguration process. And we know that downtime is undesirable and impacts SCADA operations. But there is another less obvious problem with pre-shared keys. Just because a message is encrypted doesn't necessarily mean it's trustworthy. Let me give you an example. If I divulge a pre-shared key to a deployment team installing data radios, how do I know that the key has only been configured in a radio I trust? Well, I could, of course, configure the radios myself as a trusted administrator and then deploy them to the installation team. But that's quite a bit of effort. The other problem is it's possible for someone to load the key into a radio that I shouldn't trust. So encryption is only one part of the equation. It's equally important that the source of the encrypted message is trusted. Let me now introduce a smarter way of managing both encryption and trust. Certificate-based authentication solves both problems I outlined earlier. I'll start with explaining how certificate-based authentication works. Then I'll share some examples. Instead of using pre-shared keys to define encryption, devices mutually trust each other. And the trust is based on an X509 digital certificate. Each device has a unique manufacturer's signed certificate and can store the certificate of other devices. The digital certificate is unique to each device and signed by the manufacturer. Certificates are exchanged, and this allows mutual trust to be developed and managed. Now, the concept of using digital certificates to develop trust is not new. In fact, you're probably using digital certificates every day when you use e-banking, because digital certificates form the basis of developing trust between you and the bank. Special consideration needs to be made for point to multi-point wireless networks like Wi-Fi or data radio networks. This is because there is one central device that needs to manage multiple distributed remote devices. At the top of this example data radio network, where you would normally want to manage this trust, is a device that owns the role of an authenticator. The authenticator is normally the access point or base station in a wireless network, but more specifically, it is an existing trusted device that provides a service to manage multiple supplicants. Supplicants are just clients to the authenticator. They're typically the remote devices. The key point here is that trust is only possible when both devices have shared their mutual certificates. In other words, the authenticator needs to share or acquire and store the certificates of supplicants, and the supplicants need to store and share and store the certificate of the authenticator. This allows them to develop mutual trust. A process called onboarding exchanges certificates between a supplicant and its authenticator. Now, the purpose of onboarding is to securely share mutual certificates. And of course, this might seem impossible given the devices start communication without any certificates. So to overcome this limitation, prior to the devices having the certificates, we use the concept of an invitation to securely onboard a supplicant. Invitations are generated for a specific supplicant by the authenticator using a one-time password. The invitation is locked to the supplicant using the supplicant's serial number, which makes it unique. And it's factory defined. The serial number is factory defined and read-only. The invitation is locked to the authenticator's own unique certificate. Prior to exchanging the certificates, trust is temporarily established using the one-time password, which then subsequently establishes a secure DTLS channel for the certificate exchange to occur. This allows the authenticator to exchange certificates and complete the onboarding process. Key point to note here is that invitations contain no secrets like a pre-shared key. So you can safely distribute them to non-trusted parties for use during installation and commissioning. Once certificates are exchanged, the authenticator defines the encryption key and then shares this with trusted supplicants using a DTLS channel. Any SCADA or telemetry data transmitted is encrypted using the AES GCM algorithm, which is compliant with the FIPS 140-2 NIST 800-38D security standard. A key point to note is that there is no need for a pre-shared key. And in fact, the administrator does not have access to the key, and the definition and distribution of the keys by the authenticator is entirely automated. Another benefit with AES GCM is that the key is automatically rotated every 24 hours. When the rotation occurs and a new key is being distributed, both the old and new key are simultaneously supported. So there is no downtime in SCADA communications during the key rotation. Finally, AES GCM has a message sequence number. This prevents replay attacks, ensuring the messages received are authentic. And so by definition, we've covered the encryption, the trust, and the authenticity of the security aspect of the wireless data communication. After onboarding, a trusted administrator can define the level of trust to be applied for each supplicant. I'll share an example of where changing the level of trust would be of value. Let's say a field technician removes a supplicant radio while decommissioning a site. The radio is now in the back of the technician's vehicle, still configured as a trusted supplicant. The intention of the field technician is to return this radio to the stores as a spare unit. But there's a risk that the radio is lost or stolen while it's being transported between the field and the workshop. And we all know in practice that this process can take days, weeks, sometimes months before field staff return assets to workshops. Using access controls, an administrator can change the level of trust for that device. In this example, the appropriate change is to suspend that particular supplicant radio that was removed during decommissioning. Supplicants which are suspended or disabled are denied access to the network, and encryption keys are not shared with them. Supplicants which are disabled will automatically erase their configuration and return to factory default if they attempt to authenticate on the radio network. And that's a particularly useful feature if the radio or asset happens to be stolen. You can then disable it. An administrator could also delete the certificate of that supplicant radio from the authenticator. That would achieve a similar thing in denying access, but suspension is a more pragmatic approach. As in this example, the radio is intended to be used as a spare for future repairs. And if returned to service in the future, it can then be easily returned to the authorized state without the need for onboarding again. The key takeaway here is that no changes are required to be made in the supplicant, such as a factory default or erasing of the configuration in order to deny access for that supplicant to the wireless communication network. Okay, well, we've reached the end of this session, and there are three key takeaways I'd like you to consider. The first is that certificate-based authentication provides many advantages compared to traditional pre-shared key-based encryption. Trust is just as important as encryption in order to maintain and manage wireless SCADA and telemetry systems. And certificate-based access control provides more flexibility to manage the level of trust for remote devices in your SCADA and telemetry networks. Thanks again for listening to this session. Any questions, please put them in the questions box, and we'll go through the questions if we can.
Luke, I do see that there are some questions appearing in the Q&A box. One, though, I would ask is, how do you manage certificates once you've got them in the radios?
That's a really good question. Certificates can be imported and exported. And so there are several reasons why you would want to import and export certificates. They could be because you want to take a backup. Let's say a particular site is hit by lightning and totally destroyed. Well, now you've got a situation where you need to reuse the certificates of your remote devices to authenticate them in a replacement of the Authenticator. Of course, you might think that by doing that, it will you'll have supplicants which no longer have a certificate for the replacement Authenticator. In this technology, there is a recovery password. And so the recovery password is used to transfer the new Authenticator certificate into the supplicants. So it's really a combination of importing and exporting certificates and using the recovery password if you ever end up in a scenario where an Authenticator is totally destroyed through some natural disaster or event.
We have another question in the Q&A dialogue from Fahad asking, what is the maximum distance coverage of the supplicant and the number of supplicants that I suppose could be included in a network?
Well, we've tested a radio system using certificate-based authentication up to 250 different supplicants. Obviously, it's fairly rare to ever see a radio system with that many remotes per base station. The distance is normally dictated by the coverage, the wireless coverage. It will depend on the technology that you happen to be using. In the case of data radios, it can be 60 miles if it's licensed spectrum. But in terms of the number of supplicants that can be supported, the technology has no theoretical limit. It's really about the capacity of the wireless network to support the traffic that you're trying to communicate over that network. In terms of how much bandwidth the feature consumes, it's actually very, very little. So apart from going through an authentication process when a remote device powers up, and apart from going through an onboarding process when you install a device, the only over-the-air traffic is when you rotate a key. And that is done relatively slowly so that it doesn't impact the background capacity of the network. But thanks for the question.
Okay, we do have another here. You've talked about configuring authentication. Are the different methods available to perform this?
Absolutely. So when it comes to onboarding a radio, there's a very simple method which is found a lot of popular use with end customers, and that's what we call zero touch. So zero touch is not so much about authentication as a technology, but the process of onboarding. The reason it's called zero touch is because there's no need for a laptop. Essentially, you take a radio, which is to be a supplicant, in its factory default state. So as it was delivered from the factory with a factory default configuration. You take an invitation, the invitation that I spoke about earlier, you put that onto a USB key, you put the USB key into the radio, you power the radio up. Zero touch onboarding is smart enough to detect that there's a USB key, to detect that there's an invitation, to automatically enable authentication, configure itself, authenticate with the authenticator, give you some positive feedback that it's been successful, and then you can complete any further configuration, such as configuring a serial port or configuring some quality of service rules remotely, right? But the general idea is you don't need to get a laptop out. You don't need to divulge secrets to an installer. So for example, you don't need to tell your installation team how to log into the web interface to make changes. All they need to know is I have a radio, it's in a factory default state. Of course, the other benefit too is that radio can be ordered directly from the factory. It doesn't need to go through an administration team for the administrators to do something special or secure to the device before they give it to the deployment team. So zero touch onboarding is a very popular process for the onboarding process because of how easy it is. Now, of course, in our technology, in our data radio technologies, we also cater for people wanting to migrate from pre-shared key encryption to authentication, certificate-based authentication. So we have a process where you can just generate an invite and share that invite over the air. And you go through a process of onboarding each existing pre-shared key encryption device. As you go and onboard the devices, you still end up using pre-shared key. And then at the very end, once everything is onboarded, you turn off the pre-shared key and the system is now entirely using certificate-based authentication instead of the pre-shared key encryption. There is a small amount of downtime when you reconfigure the radio and it reboots, but other than that, there's no system downtime from a SCADA perspective. And it's a much more seamless process than, for example, changing the key in a pre-shared key system.
Luke, we're almost out of time here. I do see one other question has come in from Holger. Do radios already in the field need to be updated in a pre-existing system?
Yes, that's correct. So this is a feature that's available in new firmware. The firmware was released in August last year. If you do have a Trio Q data radio system and you want to utilize this new functionality, you'll need to do an over-the-air firmware upgrade. Once you do the over-the-air firmware upgrade, the feature will be available. You'll then be able to go through the migration process that I explained earlier, migrating from pre-shared key encryption to certificate-based authentication.
I think that's all the questions we have for today, Luke. Thank you.
All right, well, thank you, everyone. I do encourage you all to open this QR code and have a look at the YouTube video that we have on certificate-based authentication. It will go through in much more detail how to configure certificate-based authentication in a Trio Q data radio system, how to diagnose it, how to onboard. And again, I appreciate many of you may not be users of Trio data radios, but I do encourage you to view this because this is a new emerging technology that is replacing pre-shared key encryption. So it will continue to pop up everywhere, from Wi-Fi devices to other radio systems to IoT and SCADA and telemetry devices. And I'm sure you'll find something useful, out of this this topic. But yeah, please open the link, have a look at the YouTube video, which goes into a lot more technical detail about how it works, how it's managed, and how it's diagnosed. Thanks again, everyone. If you would like, please reach out to me on LinkedIn, and we can connect with you there as well. Thanks, everyone. Have a great day and enjoy the rest of the user conference.